Hello, let's talk a little bit about ancient and medieval Indian mathematics. The earliest Indian mathematics uh, included some learning that was including mathematical learning, and it was passed down verbally and then eventually written down in lengthy poetic verses called Vedas, which were mostly religious. So the mathematics in those was in the Subal Sutras. There were appendices to the Vedas, and they contained instructions for things like constructing altars. So the earliest individuals recorded as doing some mathematics are those that are credited with writing uh, these texts there. However, these individuals were not likely mathematicians in any kind of modern sense. Certainly, we've talked about the importance of Indian numerals, which basically led to our current system. They were extremely important innovation, and they were in place perhaps as early as the first century BCE and more or less the current form, almost the current form. Around the 7th century, Sanskrit was used for scholarly writing. Practical concerns helped drive early advances in mathematics in India, as in most cultures. Indian rulers used mathematicians to make accurate calendars for astrology. Religion, astrology, astronomy, that connection was an important driving force for mathematical growth. And as in many ancient civilizations, there wasn't a lot of distinction between astrology and astronomy and mathematics. However, it's interesting that they didn't really do a lot of really detailed systematic astronomical observations. They did some observations, but they didn't do a lot of that. Around 500 of the Common Era is when more advanced mathematics really started to take off in India. And rather than having schools or other centers of learning, mathematics and related fields were often passed down in families. So a family would be a scientist or a mathematician and would train his other family members in that, and it was passed down through the generations that way. There were some centers of learning, but not as much. There was nothing really to like the academy in Athens, or certainly nothing like the museum and library at Alexandria. The Indians advanced trigonometry. Trigonometry was transmitted to them from the Greeks, but more and better methods were needed for astronomical and navigational problems. And in the 14th century, Indian mathematics began developing power series for trigonometric functions to improve their accuracy. There's no proof if Europeans knew of these works or if the Jesuits who went to India brought them back or not. So let's talk about just a few of the most prominent Indian mathematicians. Aryabhata, one. The Roman numeral is there because there's another one later that has the same name. He lived from about 476 to 550. That's in the Common Era. And he lived in India. There's a um, possible place where he lived there. I'm supposed to say now Patna. That's the name of it place. That's the name of the place. Uh, Kusamapura, where now it's Patna. He was the one that really kicked off mathematical and astronomical growth in India and set the tone for, well, for centuries, really. Here is the name of his most major work, and it summarizes earlier Indian mathematics and adds his own work to it. It has 66 mathematical rules, all given without proof. They cover things such as arithmetic, algebra, plane and spherical geometry, continued fractions, quadratic equations, sums of power series, a table of sines, and he gives a good approximation of pi. Interestingly enough, he did not use the Indian place value numeration system, although he probably would have known about it. He thinks that the planetary orbits are ellipses, and the planets and the moon shine by reflected sunlight, and explained the causes of eclipses, which before that in India were thought to be supernatural events. And he was actually correct in all these things and actually way ahead of his time. these didn't become commonplace um, concepts in Europe for quite a while. Brahmagupta lived from about 598 to 670, 7th century, in other words, since Common Era. Ujjain in India. He was the head of an Indian observatory, and it was something that served kind of like a university, so it was somewhat of a center of learning there. It supplied many of the rules of integer calculations, including the use of negative numbers and zero. So here we have one of the first times, maybe the first time, a concise explanation of what it means, say, for example, to add positive and negative numbers, to multiply them, divide them. So he gave detailed modern rules. For example, a negative divided by negative is a positive, and so forth. He claimed, however, that 0 divided by 0 is 0, which we now know is problematic. We leave that undefined. And contrast that with European mathematicians of the 16th and 17th century, such as Descartes and Pascal. 16th and 17th century, much later, a millennium later, and they called negative numbers absurd numbers or impossible numbers. Pascal said that 0 minus 4 was nonsense. He also supplied algorithms for solving equations and for summing series, as well as made some contributions to trigonometry. So especially in terms of the negative numbers, he was well ahead of people in Europe even a millennium later. Bhaskara I is another important mathematician. He lived from about 600 to 680 in Saurashtra, India. He did commentaries on the work of Arbindabada. He did mathematical astronomy. He worked with the sine function and indeterminate equations. Then Bhaskara II was a seriously good mathematician. He lived from 1114 to 1184 in India. This is the form of his name in India, which means Bhaskara the teacher. He was the head of astronomical observatory, same one that is Ujjain. It was a leading center for learning in India at that time. He understood the numeration systems and solving equations better than the Europeans from even centuries later. He was really at the peak of the mathematical knowledge of his time. He did mathematics and astronomy, as most of these Indians did. He had full command of negative numbers, extending the work of Brahmagupta. He also tried to make a little sense out of dividing by 0, realizing there were some problems with Brahmagupta's way of looking at things. He studied what later became known as Pell's equation, p times x squared plus 1 equals y squared, and solved that for several different values of p. He studied Diophantine problems. Other types of things that he worked on was arithmetic, interest, arithmetical and geometrical progressions, plane geometry, solid geometry, combinations, proportions, inverse proportions, indeterminate equations. And then he also discovered some important trigonometric identities. So he was kind of the pinnacle of knowledge in the and competency at the 12th century, not only in India but probably in the whole world. And we're just going to do one more. Madhava from 1350 to 1425, and he lived in the southern part of India. He did mathematics and astronomy. He used infinite series and polynomial approximations to find approximation for pi, and he gave a power series that is equivalent to what's known as Gregory's series more than 100 years before Gregory, and he did the work with the sine table. So if you notice, all of these mathematicians in general, they did a lot of work with astronomy. That drove them to try to work on trigonometry and improve that, and they made some headway with that. And they also worked on infinite series quite a bit, and polynomial approximations and series representations. So that's a quick overview of some of the Indian mathematics.